So no understanding of variables, like which is the independent variable, which is a dependent variable, or which are the independent variables. And we do not have any understanding of which algorithms to use. Within unsupervised learning, the most used method is clustering techniques. Clustering techniques are used in unsupervised learning. Clustering techniques are used in unsupervised learning. One of the most popular technique is k-means clustering. Is a popular algorithm. K-means clustering is a popular algorithm. K-means is an iterative algorithm. K-means is an iterative algorithm that divides unlabeled data into k different clusters in such a way that each data belongs to only one group or cluster that has similar properties. So k-means clustering is a iterative algorithm. Iterative algorithm is it involves multiple iterations, or multiple times it will calculate. It divides unlabeled data. Here we don't know the dependent variables, so we don't know the labels also, right? It's an unlabeled data. It will divide them into groups or clusters that have similar properties. It will divide them into groups or clusters into that has similar properties. Now, if you are looking at what it does, so it is before the data looks like this, then after k-means clustering, you will have a clear-cut grouping of data. So k-means cluster will group the data based on similarities. Based on similarities, it will create a group of data. Now, another thing you need to understand is it is a centroid-based algorithm. It is a centroid-based algorithm wherein each cluster will have a centroid or midpoint. Each cluster will have a centroid or midpoint. The objective of this algorithm is to minimize sum of distances between data points and centroid and corresponding cluster centroids. Minimize the distance between the data point and the centroid. So basically, the algorithm performs two tasks. One, determine the best value for K centers or centroids by iterations. Assign each observation to its closest centroid, K center or centroid, and create a cluster. Create a cluster. Cluster means similar. Grouping of similar data points, we call it as cluster. So this is one cluster. Green circle is there, no? It is one cluster. It is one cluster. This is one cluster. And you will have a centroid or a midpoint here. Let us see if we can get a clusteroid cluster example with centroid. I think this would be better. This. So first it will find a centroid for each thing, and then based on the distance between the centroid, the observations will be categorized. And this is called cluster. This is your unlabeled data. That this becomes a labeled clusters. Okay, so this is the process of what k-means clustering will do. Now, the k-means clustering uses distance metrics to identify closest points. Distance metrics are used to identify closest points. Most popular distance metric is Euclidean distance, and other methods like Manhattan Hamming, Mahalanobis, etc. So the clustering is based on distance. Distance is used. One of the popular distance metric is Euclidean distance. Square root of x2 x minus x1 whole square plus y2 minus y1 whole square. So if you are looking at variance distance, in machine learning, in clustering, so here, these are the distance metrics which are there. Euclidean, average, weighted Euclidean, Mahalanobis, cosine, Manhattan, Canberra, Tchaikovsky, coefficient divergence, Pearson coefficient is there, and you can see here. In k-means, we use mostly Euclidean. In k-means, we use mostly Euclidean. It is very easy to computing, but it is sensitive to outliers. The only problem with Euclidean distance is it is sensitive to outliers. Now, there are other distance. Manhattan is also there, which is again we have used. But what happens is it is also sensitive to outliers. So the outliers are an issue in distance metrics. Now, how do we can deal with the outliers? In all distance methods, what is scaling of data must be done. What is scaling? Remember, standard scaler. Before doing any calculation, we can scale the data. Like how we did in KNN, remember? Like that only standard scaler. What is standard scaler? Standard scaler is x minus mean divided by standard deviation. X minus mean divided by standard deviation, or we can use min-max scalar, or we can use robust scalar. Now, robust scalar is used when you have very huge outliers. When there are very large outliers, then you use robust scalar. If you have minimum amount of outliers or outliers are very small, standard scalar and min-max scalar will take care of them. But when your outliers are very huge, then we have to use robust scalar. And robust scalar is based on quartiles. Robust scalar is based on quartiles. So when you have very large scale outliers, then the only option we have is robust scalar. When your outliers are minimal or very small, then we can use standard scalar or min-max scalar. So in k-means clustering, scaling is to be done to overcome this thing because Euclidean distance is slightly sensitive to outliers. But the distance metrics are this. In text mining particularly, hello? చెప్పనా చెప్పు భాస్కర్ చెప్పు హలో నేను క్లాస్లో ఉన్నాను చెప్పు రైట్ Hamming distance is also there, which is used in text mining. Hamming distance is a very interesting thing which we use in text mining. When you are doing text mining, you should not use Euclidean distance. We have to use Hamming distance. Hamming distance is used in NLP or text mining. Yeah, please. So Hamming distance uses the letter positions to calculate it. And here, all the string 1 and string 2 is not matching at all. So 1, 2, 3, the Hamming distance is 7. If it is matching, it will be 0. If it is not matching, 1. In Hamming distance, if the string matches, it will be 0. If the string does not match, it will be 1. If it is 0, all zeros will be equal to 0. If it is 1, the summation of ones, you will get the 1. Here for this string, suppose we have two strings, A, B, C, D, E, F, G and B, C, D, E, F, G, H. Now you are trying to find distance between these two strings. Now, these two strings equal? No. So what will be the value? 1. These two strings are also not equal. The value will be no. No means 1, 0 means yes. So the sum Hamming distance is 7. So this is how Hamming distance is used in text mining and NLP. So we use this Hamming distance very importantly. You need to understand Hamming distance is used in card is also there, but I think this example is also. Because if you are looking at NLP jobs, they'll definitely ask you questions about Hamming distance. This is another example of Hamming distance with words. You can look at it. Hamming distance using words. Look at the bottom one. That is the second one. So if you look at the second thing, geeks and geeks are equal, 0. For and for are equal, 0. This is also equal, 0. This is unequal, 1. This is unequal, 1. These two are equal. Rest of all are equal. So having distance is 1 plus 1, 2. This is how it compares the strings. When you are doing k-means clustering on text, we do it on our NLP data, tweet data, or any other NLP data. The distance is Hamming. Hamming must be used. For numerical data, any of the metrics, Manhattan, Euclidean, Mahalanobis, and it's always better to scale. It's always better to scale the data before you run any distance algorithm. All right, can I move forward? Now, one of the biggest challenge is finding the value of k in k-means. Finding the value of k in k-means. You remember the k in KNN? K nearest neighbors. K means number of, it's an integer value. K will be an integer value, like your KNN. So the biggest challenge here is finding the value of k in k-means. Now, we used to plot a variance plot and used to find the k value, right? The lowest k value we used to, the lowest variance we used to take it. And then we used to get the k value in KNN, grid search. We used to do that. So here also we have to do the same thing. To find the k value, we have something called elbow method. Same elbow plot method. There we plot the thing as a straight line. Here we plot it as an elbow method. Is used to find optimal k value. The optimal k value is usually found using elbow method. Within cluster, sum of squares. Within cluster sum of squares, also called as WCSS, that defines total variance within a cluster So WCSS is calculated. If you are looking at the formula of WCSS, so WCSS is equal to distance PY CI square plus sigma distance PI C2 square plus sigma PI, each of them. Within each cluster, it calculates this variance, and then it adds up all those things and you'll get the WCSS. Sigma of distance PI CI square. PI means point and variance whole square. Distance is Euclidean distance or Manhattan distance or any distance. And then it will sum up all these variances and then you will get the WCSS for each iteration. Now, based on the elbow method, like it will plot a elbow point, the WCSS will be plotted into an elbow point. See, this is the plot. The WCSS are plotted into a chart with cluster number and WCSS on Y and number of clusters, and you will get the point. Let me get the interpretation also, how to identify the point. So, if there is a this image will give us the correct explanation. The elbow method and optimum, the bend. See, we have a bend here also. The point after which the variance becomes constant. Here, look at the variance, it's becoming constant. There is not much of a change in the variance. There's a big change from here to here. From here to here, there's a big change. After this, the change is smaller. After these are all smaller changes, right? So we will take this point as our optimal number of cluster. Optimal number of cluster will be the point after which the variance in the clusters become minimal. From this point onwards, it is smaller, right? Compared to this line, these lines are all smaller. So you will take this point as your optimal cluster number. So the optimal number of cluster, and the y-axis is your WCSS and x-axis is your clusters. Cluster 1, what is WCSS? Cluster 2, WCSS. Cluster 3, WCSS. And then you plot it as an elbow plot, you will get the optimal number of clusters. This is the best way of finding the correct value of K. If you want to find the correct value of K, the only method is WCSS method or elbow plot method. There are other methods also, which are used for other what you call other means. We have a very for very large scale data. When you have very large scale data, outliers will be there. Then we have a method called DB scan. DB scan is also very popular clustering method in large scale data. That's a very advanced DB scan clustering. We use it in very large scale clustering, density based clustering. This is also very well. We'll discuss it later. Okay. So DB scan is also very popular. Here we have different methods and different formulas. It's complex and all. Then we have another method, hierarchical clustering. And again, hierarchical clustering is preferred in text mining and NLP compared to K-means. K-means can also be implemented in text mining and NLP. Compared to K-means, hierarchical clustering will give you best output, better output, not best, better output. But sometimes K-means also gives you good output. And NLP text is unsupervised learning data. NLP text is always an unsupervised learning data. Either use topic modeling algorithms or you have to use clustering methods. Or you create a dependent variable like sentiment thing, and then you convert it into a machine learning problem to predict. Or you can, if it is a multivariate text data. Multivariate text means there are other variables also given along with the text data, like how we have in our what is the data set we worked on now, where we broke the text into vectorizers, words, and then we calculated the ratings, Zomato reviews. So you can use that type of sentiment analysis. That becomes a supervised learning. Because you have other variables, right? Rating is given, you have, in fact, the original Zomato reviews data is very large. Time taken to deliver will be there, how many minutes was taken. But for that, what is Zomato did was, once it got listed, it removed all the accesses. Earlier, when it was not listed on stock exchange, just like how we have the Twitter API, we used to have a Zomato API and we can use to scrape data from Zomato servers. Once the company is listed on stock exchange, they removed all the accesses. And the data which they have given is now restricted, because it's a confidential data. So earlier it was private company. It can do whatever it wants. Now, once it's listed on stock exchange, they can't do anything. It's a public limited company. Data privacy will come into picture. So these are the unsupervised learning K-means clustering method. We'll talk about the hierarchical clustering also, but this is the popular method called K-means clustering. Right? Distance methods are very important. The default method is always Euclidean. The default method is Euclidean. Apart from Euclidean, the other method we use is Mahalanobis or Canberra. Mahalanobis is developed by Indian statistician. He is an Indian statistician only who developed the distance. But for Mahalanobis, the computation is little bit calculated because it is a to the power of t. Okay. Now, all of you download the Excel sheet which was forwarded to you. So here we have two variables, x1 and x2. There is no dependent variable, only independent variables x1 and x2. Now we have to initially assume the k value. We have to assume the k value. Let us assume k is equal to 3. Let us assume k is equal to 3. Initially, you have to pick a random value and do it. And then we do a WCSS method and then we'll get the right method. That is what we do it on large data. Here we are using assume k is equal to 3. And the distance we are going to use is Euclidean distance. We will use the Euclidean distance. What is the formula? Square root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. Right? Euclidean distance we are going to use. Okay. Now it randomly selects 3 observations as centroids for first iteration. It randomly selects 3 centroids for first iteration. For first iteration, it randomly selects 3 centroids. Random selection, right? So I will select these 3, 210, 5, 8, and 1, 2. So randomly selected are 2, 10, then 5, 8, then 1, 2. Are centroids. It random selection, completely randomly it will select. Okay, now it will start calculating the distance. Dist C1, what is class 2, 10. Centroid 1 is 2, 10. So is equal to SQRT, open 2 brackets, same value, B2, X2 minus X1. X1 you have to fix it by pressing F4. Sorry. To the power of 2 plus open bracket 10 minus 10, fix it by pressing F4 to the power of 2, close bracket. Because for rest of the observations, the X1 is same, right? X1 will be the same for all the other observations. The centroid is same, right? So that's why I'm fixing B2 and C2. B2 and C2 are the centroids for cluster 1. So we are calculating distance between each observation and the fixed centroid. So first one will be 0. And then if you drag the formula down, you will get the distances for other centroids. See, if you look at it, it is calculating the distance between these two. So I will decrease decimal. Where is number, right? Got it, all of you, the formula? So we are calculating distance between all the other observations and the first centroid. The first centroid randomly selected is 2, 10. Okay, now distance C2 5, 8 is equal to SQRT, open 2 brackets, X2 minus x1, fix it by pressing F4 to the power of 2 plus open bracket y2 minus y1, fix the y1 by pressing the F4. Here we are finding the distance between all the observations and 5, 8, which is a centroid for the second cluster. Two minus 5 whole square plus 10 minus 8 whole square. 2 minus 5 whole square plus 10 minus 8 whole square. 5 and 8 are the centroids. So you got 3.6058. And if you, how do you make sure your calculation is right? For 5, 8, it should be 0. For 5, 8, it should be 0. Similarly, decrease decimal to 2 points. Decrease decimal to 2 points. Now, distance C3, 1, 2 is equal to SQRT, open 2 brackets, 2 minus 1. Fix the 1 by pressing F4 to the power of 2 plus open bracket 10 minus 2. Fix the 2 by pressing to the power of 2.
Sir, can you explain it once again, sir?
So here we are trying to find the distance between 210 and 12. 12 is your centroid for cluster 3, which is randomly selected. In the first iterations, it will take 3 observations as random centroids. Why 3? Because we assumed k is equal to 3. Then it will use these centroids and calculates the distance between the centroid and the observation. Here we calculated the distance between all other observations and 2, 10. In this case, 5, 8. If for cluster 3, 1, 2. That means 2 minus 1 whole square plus 10 minus 2 whole square, square root of. Similarly, 2 minus 1 whole square plus 5 minus 2 whole square. So it will calculate the distance. So you have to fix this 1, 2 because you have to calculate distance of rest of the observations with 1, 2. So we are fixing the 1, 2. So 1, 2 will be 0. And then we decrease the decimal to 2 points. So we have calculated the distance. Right? Using the Euclidean distance formula. Now we will assign the cluster. Cluster assign. Now, what is the lowest distance? 0. And 0 belongs to C1, cluster 1. So it will be C1. What is the lowest in this row? 3.16. So what is 3.16? Cluster 3. What is the lowest in this 3? 5, which is cluster 2. Lowest here is 0. Cluster 2. Lowest here is 3.61. Cluster 2. Again, lowest here is 4.12. Cluster 2. Here the lowest is 0. Cluster 3. Here lowest is 1.41. Cluster. So the lowest distance. So you check the 3 distances, whichever is the min, that will be your cluster assignment. The cluster which the distance is minimal will be the cluster assignment. So we have assigned the clusters. Got it? Now we have completed only iteration 1. Now we have to check in iteration 2. In iteration 2, if this cluster assignments remains exactly same, then we will stop. If the cluster assignments change, then we have to go to iteration 3. Till the point where there is no change in cluster assignments, this process will continue. So iterations play a very important role in k-means. Max iterations by default is 100, I think in Python, or I think 200, 100 or 200, we'll check it in the code. Iterations play a very important role. So if there is no change, it will stop. If the cluster assignment is changing, it will keep on calculating the iterations. Now we have to check. So copy the data, Control C, and paste it 1 row below. I'm just pasting the data here. Okay. Best C1. Now, cluster 1, we have only one observation, right? That means 210. 210 is the centroid for cluster 1 because we have only one observation. Dist for cluster 2. Now, cluster 2, we have many observations. We have many observations for cluster 2, right? Now, what we will do is, we will go back to the data points. Cluster 2, what we have? C2, control, C2, 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 and C2, right? These are all cluster 2. Now, if you see in the bottom, you can see the average here. See, there is average here, right? What is the average? 6. Similarly, we have to find out C2, 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 and C2. Again, average is 6. Average is 6. So, distance is 6, 6. Distance for C3, cluster 3. So, cluster 3, how many we have? X1, C3, and C3, 1.5. The average is 1.5. Similarly, C3 for X2 is this and this, which is 3.5. The average is 3.5. So this is how new centroids are calculated. New centroids are calculated based on the cluster observations. So now we got the iteration to new centroids. This is your iteration to new centroids. First centroids of iteration were randomly selected. First item centroids were randomly selected. Second one is based on cluster assignment. Second one is based on cluster assignment. So we got the centroids, right? Now we will repeat the same process of calculating the distance. Is equal to SQRT, open two brackets, 2 minus 2 to the power of 2 plus open bracket 10 minus 10 to the power of 2 close bracket. So this is the formula which we are using. Similarly, SQRT, open two brackets, 2 minus 6 to the power of 2 plus open bracket 10 minus 6 to the power of 2 close bracket. Here the centroids are 6 and 6. Similarly, SQRT, open two brackets, 2 minus 1.5 to the power of 2 plus 10 minus 3.5 to the power of 2 close bracket. Cluster 3, centroid. Okay. Now we will do the cluster assignment. So what is the minimum for the first row? Cluster 1. This will be C3. Oh, we have a change here. Okay. C2. This will be C2. This will be C2. C2. This will be C3. This will be C1. See, we got a change here. Earlier C1 was 1. Now C1 is 2. That means we have to go for next iteration. We have to go for iteration 3. Right? So we will go for the iteration 3. This is the new cluster assignment which is done. So we'll copy the data, Control C, Control V. Now, dist C1, you have to calculate. There are two. 2 is there, control and this. The average is 3, comma, 10 and 9. The average is 9.5. C1 is 9.5. Dist C2. C2 are this. Only 4 are there, right? Average is 6.5. Comma. Again, 1, 2, 3, 4. 5.25. 5.25. C3, there is no change, right? C3, there is no change. So we'll go with the same distance. Same centroids. C3, there is no change. So 1.5, comma 3.5. The original centroids did not, C3, there is no change. So we'll go with the same centroids. 1.5 and 3.5. But there is change in C1 and C2. 6.5 and 5.25, 3.3 and 9.5. The centroids changed for C1 and C2. C3 remains same. C3 remains same. Now we will do the distance calculation. Is equal to SQRT, open 2 brackets, 2 minus 3 to the power of 2 plus, open bracket, 10 minus 9.5 to the power of 2, close bracket. Because cluster 1 centroids are now 3 and 9.5. 3 and 9.5 are the cluster centroids for.
Sir, for all iteration, we need to consider 2 and 10 as x1 and x2, sir.
Which one?
You have taken 2 as x1, 10 as x2. Why not 5, 8, sir?
No. The centroids are different here. Na? These are the data points. 2 minus 3. The centroids are changing. Na? This is our data. This you cannot change, right? Oh, sorry, you are getting confused. Here, I have to remove the yellow. The centroids are no longer taken from here. No fill. Here also, just let me remove the centroids. Earlier, the yellow was centroids. Okay. Now, here we got the centroids differently. You get 2, 10, 6, 6, 3, which are the average points. Here also, the centroid is 3 and 9.5, not 2 and 10. These are data points. You are getting it, Mujib?
Yes, sir.
See, the earlier, initially we took them randomly as 2, 10 as centroid, but over the cluster calculations, if you see here, these are the centroids, 3, 9.5. SQRT open bracket 2 minus 3 to the power of 2 plus open bracket 10 minus 9.5 to the power of 2. Similarly, is equal to SQRT open two brackets. The first observation minus 6.5 is the centroid to the power of 2 plus open bracket 10 minus the centroid is 5.25 to the power of 2. Decrease decimal to 2. Here is equal to SQRT and two brackets 2 minus 1.5 to the power of 2 plus open bracket 10 minus 3.5 to the power of 2. So we have calculated the new distances. So we will do the cluster assignment. This is C1, this is C3, this is C2, this is C1. Oh, again we got a change. C1, this is C2, this is C2, this is C3, this is C1. So we got one more C1. Okay, so we have a change. We have three C1s now. Earlier there were only two C1s. Now we have three C1s. So that means there is a change. So I'll copy the data, Control C. I'll paste it down. Now we have to calculate the new dist C1. Now, what are the C1s? 2, 5, and 4. 3.67. 3.67 is the first one. For X2, 10, 8, and 9. 9. 9 is the second cluster point. Similarly, distance C2. So C2, we have only two C2s, right? This is C2. Why did I put C3? This is C2, right? C3, C2. C2, C2, C2. Average is 7. Average is 7. Then C2, C2, C2. Average is 4.33. 4.33. 3. Dist C3, we have a change. 2, I think C3, no change, right? So 1.5, 1.5, comma 3.5. Cluster 3 is not changing at all, right? Cluster 3 is remaining constant. Now we have to calculate the new distance. SQRT, open 2 brackets, 2 minus 3.67 to the power of 2 plus 10 minus 9 to the power of 2. Is equal to SQRT, open 2 brackets, 2 minus 7 to the power of 2 plus open bracket 10 minus 4.33 to the power of 2. Close bracket, enter. This is SQRT, open 2 brackets, 2 minus 1.5 to the power of 2 plus 10 minus 3.5 to the power of 2. Close bracket. You got the distances. Cluster assignment. This will be C1. This will be C3. It will be C2. This will be C1. This will be C2. C2. C3. C1. So there is no change. Right? C1, C3, C2, C1, no change. No change in cluster assign, iteration, stops, and final clusters formed. So finally, the clusters are formed. For this, so this is how the K-means clustering works. Very simple methodology and very effective one also. Very, very useful methodology and segmentation, widely used in marketing, customer segmentations, in HR analytics, employee segmentations, grouping of employees based on performance ratings, various variables. So you can have different variables and then you can create clusters. Okay, so each cluster will have a common centroid. And a centroid will be initially randomly selected. Then once the assignment cluster distances are calculated, assignment will be done. Then new centroids are calculated and then it will continue the process like this till there is no change in the cluster formation. So this is one of the widely used methodology in segmentations, employee segmentations, market segmentations, product segmentations. So we do this clustering analysis. This is your k-means clustering. So all of you can open a Jupyter notebook. Let me close this untitled IPNB file. Assumed. No, we have only 3 clusters, no? Iterations are 4, not clusters. Iterations are calculations, no? Distance calculations. So we finally went into 3 clusters. Here, luckily, we have 3 clusters. Sometimes it may go down to 2 clusters. Or it might go down to, see here, it's a small data. We are not doing the elbow plot. But when it's a large data, I will show you, we will do an elbow plot and we'll find out the clusters. Here we fixed the cluster as k is equal to 3. Once you give the k value, it will not change, right? If you are finding the best k value for a large data, you can use the elbow method. We have 5 columns, 3 integer, 1 string, and 1 ID. So we'll do this on this data, and then we will do it on our existing data. Okay, so all of you download the data set which is emailed to you. Hmm. So 250 observations of 5 variables. Okay. Now, all of you have imported the data. Mall data dot head. We have this data points: customer ID, gender, age, income, spending score. All right. Now we have gender, which needs to be converted into numerical. Right. So mall data dot mall data is equal to pd dot get underscore dummies mall data comma columns is equal to gender. Oh, what happened? Square brackets. So mall data dot head. So it has created, see, gender underscore female, gender underscore male. It removed the gender column and created two columns, gender underscore female and male, binary encoding. Get the miss. Yeah. But that's a numerical, now we scale them. It is not categorical, numerical continuous, na? Yeah, but they are numerical and continuous. They are not like fixed values, 1, 2, they're not discrete. If you do value counts, you'll see a lot of numbers. That means it is a numerical and continuous. Suppose if you see only 5 or 6 numbers repeating, then you can take it as a discrete scale. Here, score is a numerical continuous. Cricket score, bad number of runs scored. Is it numerical continuous or discrete? But if you convert it into half centuries and centuries, then it will become discrete. When the score is converted into a particular parameter, then it becomes a discrete value, like number of half centuries, number of centuries, number of double centuries. But if you look at the individual scores, they are numerical and continuous. That's why we calculate average, right? Average score of the batsman, average wickets taken by the average balls taken for wicket, because they are numerical and continuous. Okay. Now, X, what is X here? X is equal to mall data, double square bracket, or will drop, right? Dot drop customer ID, comma, axis is equal to 1. Okay. Now, from sklearn dot cluster import k-means. sklearn dot cluster import k-means. Okay. Now we don't know the optimal k value. We don't know the optimal k value. Optimal k value to be found using WCSS and elbow plot. WCSS and elbow plot. We don't know the optimal value of k. So we are trying to find out. WCSS underscore list is equal to empty list for I in range of 1 comma 11 colon. That means we are trying 1 clusters to 10 clusters. K means is equal to K means open bracket n underscore clusters is equal to I comma init is equal to K means plus comma random state is equal to 42. We are setting a seed so that all of us get the same cluster values. So that we get all of us will get the same cluster value, we are setting the seed. K means dot fit of X. K means dot fit of X. WC list dot append. K means dot inertia. K means dot inertia. So we are running from 1 cluster to 10 clusters. Outer value will be ignored in Python. So if you give 11, it will take only 10. And in each iteration, it will take I value as from 1 to 10. PLT dot plot, come out of the loop. PLT dot plot range 1 comma 11 comma WCSS list. PLT dot title elbow plot. PLT dot X label is number of cluster. Okay. PLT dot Y label is WCSS. PLT dot show. What happened? We don't get the plot correctly. Let me remove random state. Okay. So this is the finding methodology for finding the K value. Now, what do you think is the K value? Acha, we have taken those two variables also, right? That's why it is giving us different K value. Here, the K value is how much? 2. Because see, from that point, there is no other bend, right? Is there any other bend? You don't see any bend, right? So 2 is the point where it is bending, elbow. So for this data, 2 is the K. K is equal to 2. So we will build a final model with K is equal to 2. If you take out gender and if you take only the numerical data, then we will get a new value. Okay. But anyway, after break, we will discuss. Okay. So you can take your break, participants. So K is equal to 2. The bend is happening at 2, right? For this data, K is equal to 2. So with the gender, we are getting only 2 clusters. Small data 1 is equal to PD dot read underscore CSV. Re-import the data as small data 1. And copy this, right? I am typing. So small data 1 is equal to this. Small data 1, or let us say x1 is equal to small data 1 dot drop square bracket single quote customer ID comma single quote gender G capital comma access is equal to 1. So I've dropped customer ID and gender.
You re-imported that
Data,
CSV file.
yeah. I re-imported the data as small data 1. I will copy the elbow plot code again. And here I'll change the X to X1. If you look at X1 now, you can see there is a bend at 5. 5 clusters would be better. Okay, so we got number of clusters as, I think, you can see there is a small bend here also. Same thing, right? So I'm not sure. By default, we can take it 5 clusters, or we can take it 2 clusters only. 2 only the best option here. 2 is the option here. So your final model would be I thought if you drop those categorical where, because it's a Hamming distance thing, right? So if you drop that, I thought it might increase the accuracy. We can get a good cluster, but even if I drop it, we are getting the same thing, right? Random state is like setting the seed, because random selection of clusters is there. Na? If you don't set the seed, each of us will have a different random. If we set the seed as 42, all of us will have the same random selection. So in most of the algorithms, there is a random component. So whenever there is a random component, in Python, it is random underscore state. You fix the random underscore state as 42 or 1, 2, 3, some value you give it. And every time you run, you'll get the same output. Otherwise, every time you run the algorithm, the outputs will marginally change. In R, we call it as set seed. In Python, random underscore state. Set.seed in R. So most of the algorithms have random included in it. So you have to set the seed in R or random state in Python. Otherwise, there will be marginal differences in outputs. That's what we were getting, now some marginal differences will be there. So final model is equal to K means N underscore clusters is equal to 2. Now let us define model is equal to K means cluster. Final model K means underscore plus is equal to model dot fed x1. Okay. X1 square bracket cluster underscore label is equal to K means underscore plus dot labels x1 dot head. So you can see the cluster labels. So 202 in cluster 0, 48 in cluster 1. Cluster centers are this.
Sir, let me know why you re-imported the data, sir.
Which one?
You re-imported the data. Why you re-imported?
Because we did the get dummies, right? So it has two extra columns. See, I have the mall data which I have imported has two extra columns, right? If you look at the mall data dot head here, it has two extra columns. Get them is gender underscore female and the gender underscore male. Now I am taking only these three columns. In X1, I have taken only these three columns. I have taken only age, annual income, and spending score. I have not taken gender. That's why I have to re-import the data. So once I re-imported the data and I dropped the customer ID and gender, then we did the WCSS. We found out two clusters are better. Now, if you take 5 clusters, now whether 2 clusters are, now we are in a confusion, right? We are in a confusion now. Whether it should be 2 clusters or 5 clusters. Right, we are in a confusion now. Now, when you have this confusion, we have something called Silhouette score. Silhouette score is a mechanism that will help us to identify the best number of clusters. Post model, we have this Silhouette score. What the hell, yeah? Internet again problem, huh? So Silhouette score is a method after building quality of the clusters, whether the clusters is used to evaluate the quality of cluster. So in terms of how well the samples are clustered to each other, how the clusters are formed. Silhouette score will tell us the quality of the cluster formation. The quality of the cluster formation will be known using this Silhouette score. Now, 1 second. Silhouette score. So the value score is -1 to 1. If score is 1, the cluster is done and well separated. Overlapping. So what Silhouette score tells us is this. The value of the Silhouette score lies between -1 to 1. So this is the interpretation of the Silhouette scores. It lies between -1 to 1. One means well separated clusters. 0 means overlapping clusters. -1 means samples assigned to wrong cluster. So Silhouette score is a method to find cluster formation. Okay. So Silhouette score will tell us whether the cluster formation is good. Generally, we get 0.5 above, then it is a good cluster formation. If it is closer to 0, then we can say the clusters are very close. 0 indicates overlapping. There might be overlapping if the Silhouette score is 0. So we want Silhouette score as much as possible closer to 1. A good Silhouette score in my experience is above 0.5. If you get a Silhouette score above 0.5, your cluster quality is good. Now we have built a cluster with, we have built a model with 2 clusters, right? Now let us check the Silhouette score. What is the Silhouette score we are going to get? Silhouette analysis, selecting the number of clusters with Silhouette analysis. There is the code. sklearn.metrics, Silhouette score. X, comma, labels. Okay. The best value is 1, the worst value is -1. Values near 0 indicate overlapping clusters. Negative values, wrong sample size, right? So we want it to be between 0.5 and 1. From sklearn.metrics, import Silhouette score. Silhouette underscore score x1, comma, dot labels. So we got 0.6821603. We've got 0.68218603. So 0.68 looks very good here. Okay. Now Silhouette score will tell us the quality of clusters. Now let us build a cluster with 5 clusters. Okay. Model 5 cluster is equal to K means n underscore clusters is equal to 5. Plus 5 is equal to model 5 plus dot fit x1. Okay. Now we will do the silhouette score. x1 comma plus 5 dot labels. See, 5 clusters, 38. Silhouette score. That means quality is not good. So we have to go with 2 clusters only. So 2 cluster model is the best fit model. 5 cluster model, the silhouette score is closer to 0. That means they are very touching to each other. The clusters might be closer to one another. So elbow method generally gives us the best possible clusters.
But it is getting minimal from 5 no, sir. K equal to 5.
What is the interpretation? So closer to 1 is the best, right? Closer to 0 is bad. So 0.68 is closer to 1, 0.38 is closer to 0. So that is why we are saying here, see, we want in a silhouette score in industry above 0.50, the cluster quality will be good. Below 0.50, it will be not good. There will be very close touching clusters. That is the problem. 0.68 is a very good cluster score where we have a clear demarcation of the clusters. We want clear demarcation. We don't want any closeness or anything. So we want it to be clearly demarcated. So if you look at our scores, we got 2 clusters 0.68, 5 clusters 0.38, which is the model closer to 1. 0.68 is closer to 1. So we will take the 2 cluster model as our final model. And then we can assign the labels to the each of the observation. Which observation falls under which cluster, we will assign the label. Okay. So this is close to 1, good. This is close to 0, which is bad. Okay. So if you are running it in NLP, Zomato reviews, we have any big model? No, right? Okay. So Zomato reviews, run all. Open the Zomato reviews and run all. And see, one of the common interview question is, see, if you observe, KNN and K means are very close, right? Methodologies are also same, almost same. In K neighbors, you also find the closest neighbor. Here you are finding the closest cluster. So what is the difference? This is one of the common interview questions I have seen. What is the difference between KNN and K-means? Both of them are Euclidean distance based. Both of them assign to the nearest neighbors or clusters. The only difference is KNN requires a dependent variable. Without dependent variable, KNN will not work. Does K-means require a dependent variable? No. That is the only difference. The only difference between K-means and KNN is KNN requires a dependent variable. Y is mandatory in KNN, K nearest neighbors, whereas dependent variable is not mandatory in K-means. Even if it is there, we will not consider it. We will take only the independent variables. That is the only difference. The methodologies look very similar. Both of them use similar methodologies. The difference is that dependent variable must for KNN, dependent variable not required for K-means. Hey, they are saying day after tomorrow is not. No, you guys also decide, no? Will you guys come or not? You guys will come, right, Friday? So we have to check the K means also. We have not checked the right K means. So max iterations is 300. Max iterations is 300. Algorithm is Lloyd-Elkin auto. Oh, we have a predict also, right? We have not predicted. It has 4 features, sir. Okay, we have added cluster labels here. No, that's the problem. Hmm. Cluster label not found in access, sir. Hmm. We are dropping only one column, no? That's fine. Same, we are getting the same score. Okay, even if it automatically predicts and gives us, so we're getting the same score. So score is there. Bit underscore transform. What is bit underscore transform? Custom space. We have other metrics also. RAND index. Mutual information based scores, MI. Oh, they added a lot of things. Affinity, propagation. Fox Mallow score. Silhouette coefficient. Calency, Herbaz, etc. So they added a lot of things. Contingency matrix. Okay, why it got stuck? Zomato reviews 68, 67, 70, 72. Oh, GBM it is running. Okay. It ran for me. All the algorithms we have run, we found out neural network was the best. So clustering analysis. K-means. So for K-means clustering, data must be vectorized. Preferably TF, IDF vectorizer. So you must do the TF, IDF vectorizer for running K-means in NLP. $9,955, 180. Okay. From sklearn dot cluster import K-means. K-means is equal to K-means. We'll go with default clusters. N underscore clusters is 5 by default, right? By default, it's 5 clusters. Why is my internet also slow? So by default is 8, sorry. 8 clusters is the by default one, right? So we'll go with the by default one, right? K-means model is equal to K-means dot fit X underscore TF IDF. K-means model okay. From sklearn dot matrix import Silhouette score. Now Silhouette score okay, internet is working. Working, huh? Okay, cannot join 2.4 gigahertz. But that is not visible, no? 5G, yeah? Okay, predicted labels we have to take for each sample. So we also need to predict. K means predict is equal to K means model dot predict X underscore TF-IDF. Silhouette score X underscore TF-IDF, comma, K means predict. 4956. 4956. Oh, sorry, 0.04956. So that means the clustering is very bad. Clustering is very bad. 8 clusters is very bad. Since Silhouette score is close to 0, 8 clusters is not good. Right? Now we will use the WCSS for to find the clusters. So go to the, you have to find the proper cluster formation now. Supervised learning. You can copy the code, Control C. Paste the code and change the things to X underscore TF-IDF. Oh, sorry. I think the number of clusters should be more. We'll give more. On to 50. We got an error. What is the error? X and Y must have say, acha, shit. I didn't change the plot to here, right? T. You have to change the plot range also, right? తగ్గిందా ఇంకా అవుతున్నాయా మరి అప్పుడు యాంటీబయాటిక్ కూడా వేయాలి మరి యాంటీబయాటిక్ వేసుకోవాలి మరి. నేను రాజేష్ ప్రభాకర్ని. అది మా మదర్ బిఫిలాక్ పంపించమన్నారంటగా. బిఫిలాక్ అది ఫోన్ చేశారంట కదా, మీకు చేయలేదా? అది కాదు, ఇది మీ దగ్గర జిఫీ ఉందా? జిఫీ ఎల్బిఎక్స్ ఎల్బిఎక్స్ లేదా? సరే అయితే ఓకే, నేను తీసుకుంటాను వేరే చోట. So guys, I am running this k-means on tweet data. Sorry, I was on mute. I didn't see it. మీ దగ్గర జిఫీ ఎల్బిఎక్స్ ఉందా? ఇంతకుముందు వాడింది జిఫీ ఎల్బిఎక్స్ సక్సేనా రాశారు కదా, ఉందా షీటు? సరే అయితే నేను తీసుకొస్తాను. జిఫీ ఎల్బిఎక్స్ తెస్తాను, దాంట్లో బిఫిలాక్ ప్లస్ యాంటీబయాటిక్ అది. సరే అయితే ఇప్పుడు నేను వస్తాను. నువ్వు ఇప్పుడు అన్నం తిన్నావా? తినాలా? అవ్వలేదు, ఇంకా అవుతుంది, కానీ నేను వచ్చేటప్పుడు జిఫీ ఎల్బిఎక్స్ తీసుకొస్తాను, అది వేసుకుంది. కానీ 2 పూటలు ఇంతకుముందు రాసింది ఆయన, అదే కడుపులో ఇది ఉన్నప్పుడు. మార్నింగ్ నైట్ అది వేసుకో, మధ్యాహ్నం బిఫిలాక్ వేసుకో. నేను వస్తాను, నేను తీసుకుని వస్తాను. So tweet data, we are getting a good cluster formation. 86 also. See, if the words are clearly segmented, we'll get a good cluster formation. Sometimes the data will be too close to one another. In this case, Zomato reviews, the review data itself is not that great, right? If you are looking at bigrams, completely failed, na? We have used unigrams. You remember, we have used unigrams, but whereas we have used by, I think here tweets also we have used bigrams, right? Or unigrams? No, unigrams only. No, we have used bigrams for tweets. See, climate change, affects climate, read latest. So in this case, bigrams are working well in case of tweet data. But when you look at large scale content data like descriptions, like reviews and all, you have to be very careful with grams. Words or word will be a better TF-IDF vectorizer than a bigram. Bigram means 2 words, or trigram, 3 words. Okay. Now, if you are that Medicare data which I forwarded, not a description, which that CMS thing, Medicare claim data, which I have, I think all of you have sent it, right? In that, the description is there. Anesthesia for liver surgery, anesthesia for this thing and all. You have to create a TF-IDF vectorizer for that column. And then you should predict the average standardized procedure cost, or how much amount they paid for the procedure. Approved amount, paid amount, lot of things are there. So there you can use single words. Anesthesia, kidney, liver, like that. If the words matrix comes, what is the procedure cost? That's a very interesting analysis, whether you can identify you can predict the cost. Also, you can do cluster analysis there. So procedures you can clusterize. Which procedures, like based on cost, you can do the clusters. But k-means cluster is a very interesting thing. Okay, remember that this is a common interview question. Like linear and logistic regression, you will also get question on k-means clustering, because this is the unsupervised learning, right? And the difference between kn and k-means. And in k-means, Euclidean distance is the formula which we use. And how do you find the quality of clusters? Silhouette score. Now Python have added a lot of them. Rand index, lot of things are there. But you say we studied only Silhouette score, because they have added a lot. I am surprised to see so many evaluation metrics. They are all academic metrics. So this Silhouette score, based on that, we will see the quality of cluster formation. So any doubts, guys? You can run the K-means on COVID data also, the Wikipedia COVID data also. So if you try to find the optimal WCS here, can we find optimal WCS? Control C in the tweet data. So 1 to 100 and 1 to 100. This is X underscore TF IDF. It's really hitting mails after mails. Show some. ये अपग्रेड वाले भी दिमाग खराब करके कर देते हैं। Wrong sheet. Exploratory data analysis. Okay, anybody got the output for 100 clusters? Great. So 100 clusters also, it is not becoming a straight line. If you take 20, exploratory data analysis. 4, 4, 10. Three. Okay. 0.5 clusters of taking. If we take it as 5, 8 also, 8 we get very less score, right? 8 we got very less score. 200 and 200. So in real time large data, we won't get the proper elbow plot. So we have to go with silhouette score and elbow plot both. You are not going to native place for long weekend. I think this weekend is a long weekend, right? So Friday is holiday for you. No holiday. Then Monday by holiday? Monday is 15th August, right? Okay. It will be a long weekend then. Again, Mujib is asking, do we have class on Friday? Online guys, what do you say here? You guys, will you come or not? Or you will want it online? You guys decide. What about you guys? Online or you will come to the class? What about you? Okay. Online guys, what do you say? You want to come to the class or online? Friday? First of all, you are there on Friday or not? That's the question you should ask. Online, guys, please respond. You are there on Friday?